Have you ever written a simple Python script that you were absolutely sure should work, but it just breaks? Yeah, you are not alone. Today, we're going to pull back the curtain on those frustrating errors and talk all about Python typecasting. By the end of this, you won't just know why your code is breaking, you'll have the exact tools you need to fix it. Let's dive in.
Okay, let's look at this. This right here is a classic scenario for anyone new to coding. You ask for a user's age, you try to do some simple math with it, and boom, your whole program just crashes. So why? What is actually happening here?
So it all starts with this one line, a super simple input function to get the user's age. And you'd think, if they type in 25, then your age variable now holds the number 25, right? It seems logical. But then, you try to do the simplest math imaginable. Just add 1 to their age to see how old they'll be next year, and you get hit with this big, ugly type error. What gives? I mean, why can't Python add 1 to 25? That's exactly what we're here to figure out.
So here's our game plan. We're going to start by digging into the real root of that problem. Then we'll define what typecasting actually is, and I'll show you the core tools you need to use it. We'll also glance at casting collections, cover some common traps to avoid, and then build a solid mental model so this all just sticks.
All right, let's get to the bottom of this. What is actually causing that type error? Well, it all comes down to one single hidden rule about how the input function works.
And here it is, the one thing you have to remember. The input function always gives you back a string. Always. So even if the user types the digits 25, Python doesn't see it as a number. It sees it as a piece of text, just like the word hello. And, well, you can't add the number 1 to the word hello, right? That's why Python throws a type error. Okay, so we know the problem. How do we fix it? The answer is a really important concept called typecasting. The easiest way to think about it is like a data translator. It helps us convert data from one language or type to another. Basically, typecasting is just you, the programmer, telling Python, hey, see this thing here that looks like a word? I need you to treat it like a number. This is so important because Python is what we call strongly typed. That means it won't just guess for you in a situation like this. You have to be explicit and tell it exactly what you want.
So how do we actually do this translating? Well, you've got a few simple but really powerful functions in your toolkit. Let's check them out. These are your 4 main players right here: int, float, string, and bool. Honestly, with just these 4 functions, you can handle probably 99% of the typecasting you'll ever need to do in your day-to-day coding.
First up is int. It's awesome for turning numbery strings into actual whole numbers. But you've got to watch out for a couple things. First, if you give it a decimal, like 10.5, it just chops off the decimal part. It truncates, it doesn't round. And second, it'll break if the string has anything other than a whole number in it. Even a decimal point will cause a value error.
Next, we've got float. This one is a little more flexible than int function. It can take a whole number and just add a 0.0 to it, and it has no problem with a string that has a decimal point. But just like int function, if you try to give it a string with letters in it like ABC, yep, still gonna crash.
Now, string is kinda the opposite of the other two. You can think of it as the Swiss Army knife of casting. It's super flexible. You can throw almost anything at it, an integer, a float, a Boolean, and it will happily turn it into a string for you. The number one reason you're going to use this, especially when you're starting out, is for printing things to the screen when you want to combine text and numbers.
And then there's Boolean. This one works a little differently. It's all about whether a value is considered empty or not. Python has this idea of truthy and falsy values. So things that are 0 or totally empty, like an empty string or an empty list, Python sees all of those as false. Literally everything else in the universe is considered true.
Okay, pop quiz. This is a tricky one. What do you think happens when you run bool false in Python? What do you get back?
Surprise! It's true. So why is that? Remember the rule. It is not about what the string says, it's about whether the string is empty. Since the string false has 5 characters in it, it's not empty, so Python says it's true. This little detail trips up so many people, so definitely keep this one in mind.
Okay, so we've covered the basics, but you can also use these same ideas to convert between different kinds of collections, like lists, tuples, and sets.
So you can do stuff like turn a string into a list of its individual characters or turn a list into a tuple. But check this out, here's a really cool trick. If you cast a list to a set, it automatically gets rid of any and all duplicate values for you. That is super handy.
All right, now let's talk about a few of the most common traps that a lot of beginners fall into when they're learning about this. If you can watch out for these, you'll be way ahead of the game.
So you might hear people talk about two kinds of casting, implicit and explicit. Implicit casting is when Python just does it for you, automatically behind the scenes. Like when you add an integer to a float, Python knows it's safe to just upgrade the integer to a float to do the math. But explicit casting is you, the coder, manually telling Python exactly what to do. That's what we have to do to solve our input problem.
Okay, last but definitely not least, let's build a really solid mental model for how all this stuff actually works under the hood. Getting this one concept right will save you so many headaches later on.
So look at this really simple piece of code. First, we create a variable x, and we assign it the string 10. Then, we create a new variable, y, by casting x to an integer. Now, here's the big question. After that second line of code runs, what is the original variable x? Is it still a string, or did that int function change it into a number?
And the answer is, x is still the string 10. This is the golden rule of casting you really need to remember. Casting creates a new value. It does not change the original one. It's what we call non-destructive. It just reads the original value and then spits out a brand new converted copy for you.
And there you have it. That's typecasting in a nutshell. It's a really simple concept once you see it in action, but it is absolutely essential for writing Python code. Now that you have the power to translate your data from one type to another, the only real question left is, what are you going to build first?